So, welcome to Massive Open online course on chemical process intensification. In this module, we will discuss methods and tools for achieving sustainable design. In the previous notes, we have discussed the scale and stages of design for the sustainable design and processes. And in this lecture, we will cover this under this method and tools, how to determine the process intensification solution and also what should be the mathematical problem formulation. A brief overview of the different solution techniques will be considered here. Now, if we consider the methods and tools for the sustainable design, in that case we have to consider that particular that scale and also unit operations. And if we consider that the simple process like as shown here in the figure, that like reactor, distillation column, reactive distillation, even reactor to the membrane reactor, you will see there will be a conversion of this the flow of this unit operation scale to the unit operation, then task, and then that final stages of that unit processes. So, here now if we consider that for the sustainable design, and if we do the separate process of reaction engineering the reactor and distillation in the distillation column, we have seen that there are that more energy losses, even sometimes will be less yield, and also other different difficulties in the operation of the that processes. So, conjugating these two operations like a reactor and that distillation, where this conjugation of these two process of reaction and separation process, we can say that we can design of the reactive distillation just by considering the that economic and also some other operational factors to get this sustainable design. And some other example like reactor to that membrane for the separation, then reactive or membrane reactor we can say there. So, in this way if we consider that certain that processes and in that case to design the general sustainable process, in that case you have to that formulate these things by mathematics, and then for that mathematical expression you have to consider the different parameters. And in that case if we express this by mathematical expression, like you have to minimize or maximize the objective of several operating variables where this sustainable design to be obtained based on this or subject to this some other some parameters here. In this case this equation here given that 1 to I think 5, that f objective as a function of that is x, y, d, z, and that theta, and subject to h 1 into x comma y comma d comma z comma and theta, that should be equals to 0. And under this limit of upper bound and lower bound, it will be as that b lower bound should be less than equals to what is that b 1 x plus b 2 y, where these things should be less than equals to b upper bound. So, in this case and also some other parameters like h 3, another parameter is a function of x and y within a upper bound of this h 3 l to h 3 u, and also that like g l to g u, and g is a function again based on that operating variables. Now, x is the set of design and optimization variables, y is a set of binary decision integer variables, and d is equal to a set of equipment variables, and also z that given here in the equation. a set of thermodynamic variables, and theta is set of process specification, and y the set of binary decision integer variables should be 0 or 1, and in that case you will say that objective function should be a set of binary decision integer variables. That variable should be 1 to j, and which will be greater than equals to 0. And in this case this h 1 as a function of x, y, d, z and theta will be equals to 0. This equation represents a system of linear and non-linear process model equations, and the process models are considered at a steady state that will consist of phenomena and mass and energy balance equations. So, in general the process models can be used for steady state, dynamic and or both modes. So, this equation is very important whether you are representing the model equation as a linear system or non-linear system. So, the process models should be considered generally for the steady state which will consist of phenomena, mass and energy balance equations. Whereas, these equations B that is B 1 x plus B 2 y and H 3 as a function of x and y, these equations represent the process flow sheet, physical constraints and equipment design specifications. For example, the process flow sheet structure and equipment design parameter. So, by these equations you can represent this process flow sheet physical constraints. And also this equation like g less than equals to g into x y as a function of x and y within a limit of lower to upward, this equation represents a set of intersection constraints that the feasible intensified flow sheet alternatives must be satisfied based on this equation. The constraints are intensified equipment design specifications and performance criteria, which will be sustainability matrix and life cycle assessment factors. So, these constraints to be considered for your that optimization process for your sustainable design. Now, equation 1 to 5 that I told that in the beginning that what are the equations can be formulated as a that MINLP problem, when the objective function and or constraints include both linear and non-linear equations and binary integer variables for the selection of phenomena, tasks and unit operations. In order to manage the complexity of finding the best or optimal solution to the synthesis intensification problem, an efficient and systematic solution approach is required. So, this MINLP that problem should be considered when objective function or constraints both will include linear and non-linear equations, and also binary integer variables for the selection of phenomena and tasks or unit operations to be considered. So, MINLP is mixed integer nonlinear programming, and also one method is the decomposition based solution strategy for this where problem is decomposed into a set of sub problems that are solved according to the predefined calculation order. Most of the sub problems requires bounded solution of a subset of equations. The final sub problem is solved as a set of NLP or MILP. What is NLP? NLP is called nonlinear programming, whereas MILP is called mixed integer linear programming. So, one method to solve this problem it is called decomposition based solution, and in that case the problem will be decomposed into a set of sub problems and that are solved according to a predefined calculation order. Most of the sub problems requires bounded solution in that case, and the final sub problem is solved as a set of that is mixed integer linear programming or nonlinear programming. Now, what are the that alternatives for the feasible and intensified flow sheet? First of all, you have to consider the process model equations, and which will be actually solved subject to the constraints that is defined in equation number 3 and 4 that earlier I have given, in order to generate a set of flow sheet alternatives. These alternatives are then evaluated using the intensification performance criteria. Equations 5 is in order to select a set of feasible flow sheet alternatives. So, here you remember that equation that I have given, that would be sequentially 1, 2, 3, 4, though it is not mentioned here, but it will be considered as 1, 2, 3, 4, 5. Now, for the remaining flow sheet alternatives, the objective function value equation 1 is calculated and ordered. So, in that case you have to remember that the flow sheet alternatives that give the best optimal objective function value that are selected as the more sustainable design. So, to identify the feasible and intensified flow sheet alternatives, you have to consider those model equations that is given in equation number 2, and that should be solved subject to the constraints given in equation number 3 and 4. So, these alternatives after that you have to evaluate using the intensification performance criteria, and then finally, equation 5 in order to select a set of feasible flow sheet alternatives, and for the remaining flow sheet alternatives the objective function value, that is equation is to be calculated and it should be ordered. Now, as per performance criteria, improvement and performance criteria for performing the process intensification, we can say that different performance criteria is there. So, there will be effective use of resources, there will be new processing policies, equipment capital investment, utility consumption, sustainability matrix, life cycle analysis factors, and integration of unit operations or sustainable technologies like integration of tasks, integration of phenomena, or all should be considered for the as a performance criteria. So, improvement will be that based on that raw material utilization, separation efficiency, energy efficiency, waste minimization, even process economics, even environmental outlook there. So, in this case here in the table star will indicate the performance criteria that are used as a measure of improvements. So, in this case multiple performance criteria can also be used. Now, what are the different solution methods to get that optimized that process design? There are generally 3 types of methods. One is called heuristic based methods. It generally consists of sets of heuristic rules and also mathematical programming are one of the important that solution methods among the 3 methods of this given in the slides. So, mathematical programming is an optimization problem which is formulated and solved using a generated superstructure that contains a finite number of unit operations and their corresponding interactions and also interconnections. Now, hybrid based methods is also another important, this is basically the know-how of the previous 2 methods like heuristics and mathematical programming, and in that case that based on the knowledge of this heuristic and mathematical programming, the hybrid method can be procured or developed to get that optimized solution. Now, for process intensification, unlike the process synthesis, heuristic based methods and mathematical programming methods, these 2 methods for the design of entire chemical and biochemical process have not yet been actually proposed as per literature. However, the methods for the intensification of the specific parts, that is reaction and separation of a process have been actually proposed in the literature. So, for heuristic based methods, it is generally rule based design, decisions based on process know how, and thermophysical properties that have been proposed for the use of reactive distillation and reactive divided wall columns, as shown in the figure in the slides. Here see in conventional distillation column from the left of this figure, A and B will be that reactants to be sent to that and to be separated, that A and B, and also the dividing wall column there is another option to get that process intensification. Here A, B, C will be supplied to that dividing wall column, where you can separate it, that A B and B C at the bottom and the top of this column, and after that this B should be separated from that A B C mixture, and then that A will be separated from the top of the column and C will be separated from the bottom of the column. Whereas, if you are using the reactive distillation column, that A and B will be used for reaction as well as the separation of this product of A and B and unreacted A and B, and also product. So, that product should be taken care after separating of A and B from its top and bottom parts of the reactive distillation column. And that reactive dividing wall column also there. First of all, this A and B will be giving the products at C, and after that or A will give you the product B and C, and you have to separate that A B C by this wall separated that is column, dividing wall column. So, here we will see that B will be separated from this A and C from the top and bottom parts of the column. Another important examples here, suppose if you are going to actually produce that methyl acetate from the methanol and acetic acid mixture. First of all, you have to allow it at the reaction of this methanol and acetic acid, and whatever products will be coming, and that product should be separated by that distillation process or extraction process. First of all extraction and then distillation, then distillation. Now, finally, that after reaction to the reactive extraction and distillation, you can get from the top that methyl acetate as a product, whereas from bottom you can have this water solution from the bottom. So, in this way you can design that sustainable design of this certain process based on this heuristic method. For mathematical programming based methods, in that case these methods actually generally for sequencing and selection of divided wall columns, and in this case reactive distillation as well as reactive distillation plus membrane separation can be considered here. So, if suppose there is a methanol with catalyst should be that used for that reactive distillation, here like PC and PG are to be used, and that PC, and after that after reactive distillation it will be separated as that methanol and DMC, and as a bottom product of PG and catalyst, and also after that it will be that separated by that membrane and to get that methanol and DMC, and by vapor permeation that you can actually separate that DMC from that methanol. Of course, that DMC will be some extent will be there with the mixture of methanol, it will be sent back to the distillation column. So, in this way that combination, or you can say that integration of this process can be used, and mathematically expressing this process phenomena, then you can of course solve based on the operating variables what are considered in this case. And hybrid methods for process intensification have been proposed for intensification of an entire chemical and biochemical process and specific parts of the process that you have to note down here. And for intensification of entire process, Ludge et al. In 2013 they have proposed a phenomena based method where the process phenomena are combined in order to fulfill tasks. Like once these tasks are fulfilled, the combined phenomena are translated into unit operations. Such a method that will provide the opportunity to innovate, because the generated unit operation from the phenomena may either be novel or maybe new, innovative or existing there. So, that is why phenomena based method can be used to fulfill the task, and in that case you have to combine the phenomena that should be translated into unit operation. And based on that concept, it is actually similar to the computer aided molecular design methods, where molecules that is similar in concept to unit operations are designed, that is subject to a set of target properties, and using functional groups, that is different combinations of the atoms which are similar in concept to tasks, or you can say that atoms that is similar in concept to phenomena as the building blocks. So, you have to make a building blocks for this phenomena based approach, where the set of target or desired properties to be identified, and using that functional groups of different combination of atoms which are actually similar in concept to tasks, that should be also taken care, and also atoms that is similar in concept to phenomena, that also to be identified to get the solution based on this phenomena based approach. Now, for these atoms are to be combined, that will give you the functional groups, and then it will be combined to that molecules, and after that what will happen, that phenomena building blocks to be made based on this atoms or combined phenomena, that is phenomena based building blocks, and it will be combined to give you the simultaneous phenomena building blocks as compared to that atoms to molecules. And then if you combine this simultaneous phenomena building blocks, it is called that SPB, that is instead of PBB, that is the set of PBBs, it is called SPB, it is called simultaneous phenomena building blocks, and it will be combined to give you the final operations there. So, based on the concepts of atoms to the molecules, where the atoms combine to functional groups and to molecules, the similarly you can make that blockwise, that is block concept of the phenomena based blocks you can develop, or you can make to give you the final operations there. Like phenomena building blocks, it will be combined to that simultaneous building blocks, and then finally it will give you the operations based on that combination of these phenomena based building blocks. So, by combining building blocks at lower scales, that is moleculars or PBBs, a new molecules or a new process flow sheets you can say are to be actually developed to get that design. Also, a small set of building blocks are used for representing that multiple molecules and the flow sheets there. And most of the process can be represented by using the following 8 phenomena based process blocks, like mixing, including two phase mixing, and heating, you can say that cooling, reactor, phase contact, phase transition, phase separation and dividing. So, these are the different phenomena based process blocks. So, if you are combining these different phenomena based blocks to form that PBB, and after that combining more PB, it will give you the simultaneous building blocks, and finally you can get the final operational flow sheets there. So, one or more PBBs are combined to form that SPBS, it is called simultaneous phenomena based building blocks, subject to a set of combination rules that fulfill the objectives of any task there. Example, suppose if you are considering that reaction and also phase transition. So, this reaction and phase transition phenomena based building blocks can be combined to form these simultaneous phenomena based building blocks, because the energy that is from an exothermic reaction can be used to that drive simultaneous reaction separation tasks. So, that is why you have to combine these PBBs to form that simultaneous PBS, where that energy and exothermic reaction to be utilized to drive the simultaneous reaction separation operation or task. Final, that SPB for the RPT, that is reaction and phase transition combination, that including other phenomena also can be expressed as this by mathematics, like that M will be is equal to 2 PHM, that is 2 phase mixing, that is equal to reaction, that will be the PC VL and PT VL and PS VL. VL means vapor liquid, PC means phase contact between this vapor and liquid, phase transition vapor and liquid, and phase separation vapor and liquid, where that PTVL is a PPV representing a vapor liquid separation task. So, a combination of these SPBs forms operations that are translated to no or new novel unit operations that constitutes the final you can say more sustainable flow sheet alternatives. So, that is why final SPBs for this combination of the PPBs can be formed based on that that building blocks of that phenomena based variables, and combination of those this SPBs will give you the final that flow sheet alternatives. Now, a combination of these SPBs forms operations that are translated to no or new unit operation that constitutes the final flow sheet alternatives. So, based on this we can here have this reactive distillation, where reactive distillation will be considered as the unit operation, that is a reaction separation task. So, in this case you will see there where condensation and the heat exchanger to be used there. So, in that case that operation will be based on that mixing, that contact, even two phase mixing, even PC, that is vapor liquid phase contact, and also that phase transition will be there between that vapor and liquid, and also phase separation will be there. So, in this way that M to PHM that will be equals to R is equal to PC of VL and PT of VL and PS of VL, and in this way you can form this operational flow sheet for this reactive distillation. Now, I will suggest to read further about this that operational methods or solution method to get that final solution of this optimization, or that representing the process intensification design based on the different constraints and different phenomena based variables based on which you can form a building blocks, and which is based on the concept of that atoms to the molecules, and how then this PPB, that is phenomena based building blocks can be formed based on the phenomena of the variables, and also from that PPB how it can be formed to that simultaneous phenomena based building blocks, which will give you the final alternatives of the process flow sheet. And that is why we can use that concept of that atoms to molecules for the design of the sustainable process based on this building block concepts. So, I will suggest you to go further this textbook to know about this solution of the techniques of sustainable design for this process intensification. So, thank you for this lecture today.